Hello and welcome back to video feedback before all hands on DAQ. This one should be a short one and it's digging deeper into DAQ. And what I'm essentially going to do is just go from top to bottom through the source code of DAQ and kind of just explain what's there, which should help demystify some things. I have worked on developing tests for DAQ and I've added one feature to the DAQ reporting system. So, full disclosure, I do not claim to be an expert on how DAQ works or why DAQ is structured the way it is. But anyone who's downloaded the repository and tried to run it and tried to use it might just be a bit baffled by all these folders, and they've all got shortened names. There's bin hack, there's CMD, and here there's a load of scripts which do stuff. Should I use these scripts? Should I run them without running DAQ? There was a post on the forum which I remember from a user somewhere who had run the build command of DAQ, so your standard command build, or even maybe before that. Anyway, what they'd seen is there was a folder called Docker, and there were a load of Docker files, and maybe they'd run command build, and they'd seen that DAQ had generated a lot of Docker containers, such as this. So we've got DAQ test TLS, DAQ test password, and what they tried to do, because they were kind of a little bit confused, which is understanding, is just run something like docker run DAQ test switch. So if you do that, well, what on earth is happening? Well, nothing at all. If we run, I don't know, something else like DAQ networking, and you just do docker, let's go back, docker run that, so that will just do that kind of thing forever. So that is quite an understandable conclusion to draw. Let me just kill that for a second. Ooh, well, thankfully our handy kill Docker containers command will work, and it's gone. Yeah, that's a reasonable conclusion to draw. DAQ builds Docker containers and you run them. That is not the idea of DAQ. DAQ is a system which orchestrates a load of Docker containers together, and there's a load of plumbing which does that in here. So the point of this is just to kind of go over what's going on. And we'll do it in GitHub, just because. So, top to bottom, we have the .idea folder. And if we Google something like, what is a .idea folder? That is something for IntelliJ. So anyway, here we are. We're here in JetBrains, and it's a that's a hidden folder in Unix-like systems. So if we ls there, then we won't see it. If we ls -la, then you'll see at the top there, we have, there we have the .idea folder. For some reason on GitHub it appears at the top. And this, the collection of files in here are for the developers of DAQ, because some of them use IntelliJ, and there's a lot of Java in DAQ, so these are just settings that are recommended for this particular project. Within the bin folder, when I first started off on Ubuntu, a couple of years ago now, more than a couple of years ago, I thought bin was something like the recycle bin. It's a contraction of the word binaries. So these are a collection of bash shell scripts, born again shell scripts, who, well, not who, they're not persons. This is what DAQ runs. So the physical sec script, we discussed that. For example, when we were running DAQ, we were running DAQ with a real device. The physical sec script is run if you have a local switch configuration, and it tests the communication to your switch. It'll do some things. It'll clean some things. It'll check your configuration is okay. And then it will ping your chosen control plane that you've set up in system.conf. Just close down Slack because that might get a little bit ridiculous. There's also a trigger Travis, user enable, which run by other things. There's setup DAQ, setup base, setup dev, setup.1x, setup stack. So some of these scripts you run yourself, like bin setup dev, for example, but other scripts DAQ will run from within the framework itself. Bin hack, I don't know fully about this, but there's something to do with OVS where there's a bug. Just setting a timeout of 30 or something. I don't know what that argument's for there, but there we go. In the CMD folder, these are things that you probably will run yourself mostly, and this is where command clean. So command clean is here. It just removes a load of things. This is where command build is, and this simply get some config things, and will, I presume, look in your build conf files within your config modules and build those Docker containers. So there's Docker build in here. If do images are skipped, then we're skipping in build event. That's what it is there. There is a faucet script, which some of these scripts as well, I think DAQ will run from within the framework. Speaking of the framework, here it is. DAQ, all of these files here ending in .py are obviously Python files, written in Python 3, mainly written by Grafnu, this guy here. And this is what DAQ is. So if we were to do, well, this is what the framework side of DAQ is. The orchestration of running generic containerized device tests is all done from there. So most of the logs that you'll see from here will be from these Python files right here. So there's a Python file called report. That one does reporting. Network, that does network stuff. There's an HTTP server, does some things. There's GCP. .py, which connects to various Google Cloud Platform services, which is what GCP stands for. There's a DHCP monitor, which presumably monitors from DHCP. But just to make it really, really obvious, info GCP loading GCP credentials from, if we just copy this bit here, and we search in our source code for that, you can see that is in gcp.py. Thankfully, the developers are very concerned, and rightly so, with adequate logging and monitoring, which is another reason I love DAQ, because it's really easy to, well, once you get used to it, it's quite easy to debug, because there's a lot of information about what is going on. So gcp.py, that has a logger called GCP right here, and that's what we see. Same thing with the runner. If we just copy this reading test definition file thing, then that will be in runner.py. That's about it. Logger info. Once again, logger is set up at the top here. So why is that useful? It means that if you are comfortable reading source code, or if you want to find out why, if you want to find out why or how a problem is happening with your test or your device, and you want to see what the code is doing to produce a problem that you're seeing within the logs anyway, and elsewhere, you can simply just have a look at network there. Just have a look at network.py, and just have a look at the source code of what is happening in there. And if you would like to report an issue, then you can reference a line in any given file, etc., etc., etc. Is that still running? Yeah. Okay. So next, in the Docker folder, these are the bare bone Docker files that make up DAQ itself. So aardvark, we've discussed that quite a lot before. That's the base image. Everything else is built upon. So we install some stuff, and we're basing it on Ubuntu Bionic. Ubuntu Bionic. Oh god, this is, I believe, the one that has some sort of Bionic Beaver. There we go. So that's 18.04.3. So for example, if you wanted to download the source code and you had a feature that was only supported from a different version of Ubuntu, for example, then you could change that yourself if you did so desire. Not recommending that, because that might make a lot of other things break in DAQ, because as a lot of people say about the project, there are a lot of moving parts. Yeah, so there's also networking, there's test binding, and so down here at the bottom, test ping up to test backnet, these are, as I think I've referenced before, the tests that are included within DAQ proper. If you were to run DAQ without any configured modules that you'd find in the subset, then those tests would run if you didn't disable them yourself. Docs, fairly self-explanatory. These are the most up-to-date versions of the documentation for explaining DAQ and indeed configuring DAQ. Working on DAQ, the most important ones for me were pubber.md. If you've stumbled across the cloud tests in DAQ, then this really helps in setting up your Google Cloud Platform account and project within that account properly, so that the cloud UDMI test will work. Also, there is orchestration down here, which basically explains how DAQ sets up things to do with Faucet and OpenFlow, and a helpful sequence of events. There is a quick start MD, which is kind of a more well, it does what it says on the tin, like quick start stuff. Anyway, so those are the docs. Firebase in here, you'll see a load of JavaScript functions. And these do things to do with Firebase. Obviously, that's so all the stuff in the Firebase folder. That is how the dashboard itself works, and how the dashboard communicates both with Firebase and with the local machine that is running DAQ. There's also the deploy script, which we ran before when we were discussing DAQ's Firebase dashboard, which could have been part 4. Yeah, part 4, part 1, and part 2. Okay, moving on. So we have functions. So I believe these functions here are to do again with the cloud tests. So the cloud test, in a nutshell, sets up a dummy device which is called a pubber, and then the test runs another little utility called validator. The dummy pubber device spits data up to GCP, and then the validator validates that the packets being sent out are of the right format and whatnot. So those are to do with those. There's Firebase write and a state shunt. In the MISC folder, this, MISC miscellaneous. This includes the test site, which you can use to, as kind of inspiration to set up your own local site. This is also the test site here is what is used for the integration testing of DAQ. So when Travis, so I'll cover this again later on, but DAQ uses, so look at the commits here. Then we can see there's some ticks and some crosses by all these commits. So happy days, this particular commit, or this particular build, passed. And if we have a look on Travis itself, Travis CI, continuous integration, we can see that Travis has run a certain number of tests. Yeah, base many orgs and topo. So base many orgs auxiliary tests and topographic tests. And if we go back to where we were for a second, I should have opened new tabs, but didn't. So Travis uses this configuration here to run its tests. So the MAC address is here. Travis builds DAQ from scratch, tests that works okay, and then it runs DAQ with these devices. And that's basically what that is. So MISC is also where a lot of defaults are, and also where a lot of examples are for configuration. So we've already discussed starting up multiple flow containers. That's kind of here, start multi, start discover, start base, start work, networking, etc., etc. Examples of configuration and other little tests like test ping, test mudgy, and test hold. That's a very helpful place if you ever get stuck or forget how to configure things. Mud files. I am no expert on mud files at all. Mud files. I always forget this. Manufacturer usage description. From what I understand, it's a file that it describes what a device, an embedded software device, is doing. So these ones here are an example of a mud file that describes a certain device doing a thing, aka, not aka. in this case, a generic backend device, and there's other ones in here as well. Okay, so that is modifiers. There's mud ACL, ACL access control lists, and presumably this is a little Java utility that enforces those ACLs or makes them. Pubber, already discussed before, there is a test called, well, there are cloud tests, and Pubber, there's actually, as I said before, a helpful thing in the docs, pubber.md, which explains what that is. So yeah, that's what that is. Pubber is loaded Java. Qualification, this is where generic examples of device module configs, device type module configs, minimal device module configs, and system module configs would be. So if you ever forget how to enable certain modules, or enable or disable certain modules, they're all JSON, so they're all quite easy to understand by both humans and machines alike. Device state sheets, all sort of stuff. This is the template of what DAQ currently works. So this of course could change, and extra keys could be added, or perhaps taken away in the future. So keep an eye on qualification, these examples, to see what DAQ supports in JSON configuration. What's next? So we have some schemas in here. DAQ champions the use of UDMI, which is the Universal Device Management Interface, which you can read about it later, but that's what that is. And in the schemas folder, we have a simple schema. Schema in this, oh yeah, we have some shapes going on here. Schema in this context means that for a given device that spits out data to the cloud via MQTT or via whatever you want, AMQP, etc., etc., etc. The data must be in a certain schema, because you don't want, if you are installing 1,000 devices in a building, it's not a good idea to have all of your devices spitting out very, very slightly different structures of data, because then it gets hard to validate, and it gets hard to catalog and sort effectively and put it into your data lake or display it on your end user mobile application or whatever. So that's what the schemas is. So there's a full example of every single concept within UDMI, and that aims to be as generic and as useful as possible. Right, subset. So this is where I'm not entirely sure why it's called subset, but it's a subset of DAQ, and these are kind of tests that have been added by other developers that are external to the development of the DAQ proper, so the DAQ framework proper. So these can be thought of as loosely modules. Of course, the modules, as we've discussed, are defined within, well, by Docker files basically. So this module is called UDMI. We are adding UDMI, so that is one module there. Pen test in here, there isn't a module called pen test, but there is a module called brute, a module called discover, and a module called nmap. The build.conf again describes the build step and the addition and the removal of various modules. Within modules, there are different tests. So for example, in the switch test, we have a module manifest.json. So the module is, so Dockerfile test underscore, after the underscore, that's what the module is called, switch. And then the module manifest, if it exists within one of these subset folders, that tells you what tests are within each module and a helpful description. And that is exactly what is printed out on each report that DAQ produces. So subset are extra tests that DAQ runs. Testing. So we've kind of just go back to the commits for a second. We have briefly discussed about kind of 5 minutes ago the DAQ uses Travis CI to orchestrate integration testing. And if we have a look at these names here, so Travis runs tests that you configure it to run with kind of an environment configuration. DAQ test topo, DAQ test org, DAQ test many, and DAQ test base. So remember that, so base, many, orgs, topo. If we look in the testing folder, we can see many, base, orgs, and topo. So when Travis runs a test here, so let's have a look at the logs of this. They'll be very long, so I go in very in any detail. So all this stuff here is produced by, first of all, the setup step for Travis, and then this testorgs.sh. So what test, for example, what testorgs.sh does is we make a pubber, some little utility function here to capture the test results. We create a configuration for a local test site, so we're going to be using, we're copying misc test site here. And then by and by, we are running DAQ like that, and then we're capturing the results, and then we are printing all the results out to a test, out to a testing report, and then so test orgs out.h really looks at the logs of all that thing, or all the logs that you choose to put in here, so that if anyone makes, there we go, got some extra sections here. If anyone makes a change to any of the tests, so if someone makes a change to protocol.backend.version, for example, and the output is not the same, or the output is not what the developer was expecting, then the Travis test will fail. So that's what's in the testing directory of DAQ. Topology. If I'm honest, I'm not too sure what this is, but I'm presuming it's to do with some Faucet network topologies. Sensor bond. Yeah, this is configuration for Faucet engage and stuff like that. Utils. It's a little tiny file which just has some bash functions. That's what they call their bash functions to help with the generic pricing reporting from any given DAQ test. The validator, finally, is a bit of Java that validates schemas, data schemas from IoT devices. Then, all in all, Docker ignore, kind of obvious get ignore, pylon RC, Travis.yaml, which sets up so base many orgs topo. If we go here, then you can see if the back button works. Thank you. That Travis is running the tests that are defined within this Travis.yaml. So that's what it is. And yeah, it's got my authors contributing. Yeah, it's a quick note about contributions. If you would like to add things to DAQ, then make sure you head over to this link here. The project is kind of run in association with Google and Google developers, so make sure you click that link if you want to do that. Code reviews are done by pull requests, and yeah, just make sure you adhere to standard guidelines. The README is what's here, and finally DAQ IML, which is something else to do with IntelliJ. Okay, so that is digging deeper, again, digging deeply but shallowly at the same time. Shall overview of what folders are. Of course, this being a new and young project, this folder structure is subject to change. But since version 1.0.0 was released last year on the 17th of June, it shouldn't change that much. So maybe this video won't go out of date that quickly. Anyway, fingers crossed.